we denote its components in some basis. You can write components only if you choose the basis. We denote its components in some basis as T I1, I2. So how many I should write? The superscript. Superscripts n, because vectors are in the superscripts. So I2, etc. In and J1, J2, etc. Jn. This is the tensor. So any tensor, if you don't have any one forms as input, then it is called a contravariant tensor. If you don't have vectors as an input, it's called a covariant tensor. If we have some one forms and some vectors, then it's always called a mixed tensor. Correct? So this is. So now, do you understand why do we write superscript and subscript, and how many superscripts, how many subscripts? It all depends upon what is the input to this box. So tensor is like a box. Okay. So if you give your inputs, then you get scalar as an output. It's a function. Okay. Now some note on the indices. We talk about two types of indices. First one is called dummy indices. Dummy indices are generally the repeated indices. Since repeated indices with one on the superscript and the other on the subscript are summed over, okay, so something like this. So A alpha, B alpha. Alpha is repeated, so this is summed over. So it doesn't matter whether I write alpha here or beta here. So this is same as the A beta, B beta. So here alpha is dummy. Since it is summed over, that index does not make any sense, or does not carry any meaning. On the other hand, there are certain things called free indices. Free indices are important because they should be preserved on both sides of the equation. For example, if I say A alpha is equal to some lambda beta alpha beta into B beta. So beta is summed over, but alpha is free. So this should be conserved. On the right side also you should have an alpha, left side also you should have an alpha. If you don't have those free indices are not conserved. I mean, conserved is a very physical term, but here I am simply saying they should have same position and same number of free indices on either side of the equation. If it's not there, that means you didn't write the equation correctly. So this alpha here is a free index.
So the order matters, alpha, beta, beta.
You should have, order doesn't matter actually. Then alpha is a free index.
Is there any situation where both are subscripts and both are superscripts? Is repeated. Even A alpha, B alpha, or alpha is subscripts. Is there any meaning for such a notation?
Say that again, I didn't do this. A alpha,
A alpha, B alpha, where alpha appears both in subscripts.
this kind of a thing.
Is there any meaning for such a notation?
Yeah, you can have, but here there is no summation. So what I am saying, see there is a little bit of confusion here because some books do not bother about this superscript and subscript. So for example, Riley Hobson, which I suggested as a book for this workshop, does not bother about this superscript and subscript. They will somehow if it is repeated. So you have to be a little bit careful. But proper, because that is again because there is no distinction between, Riley Hobson does not bother about non-Cartesian states, non-Cartesian spaces. So in Cartesian space there is no difference between superscript and subscript. Okay, so but in the notation that I am developing, this A alpha, B alpha is not summed over.
What does it mean? What type of explain this?
This is like a free text. Yeah. So A alpha into B alpha.
So this is in Cartesian use.
So alpha can take any value. That's all it is. When it's a free index, what does it mean? It means that A1 can be, if you take alpha equal to 1, you should take alpha equal to 1 here and sum over beta. If you take alpha equal to 2, you should take alpha equal to 2 and sum over beta. So you should treat it like that. So given any alpha. So any questions at this point? So I think now I have defined what a tensor is. Tensor is a linear scalar value function of certain number of one forms and certain number of vectors. The rank of the tensor is sum of the number of one forms and number of